Hello students, hope everyone is fine and doing well. So we are going to start the miscellaneous exercises and different, maybe we'll see the examples whichever you can solve. Okay, until 5.7 we already discussed the question answers. Then you have mean value theorem, which is removed from the syllabus for this year. So I have one question from the exercise 5.7. Just we'll solve that one, then we'll move to the miscellaneous questions like 17th question. Y equals to tan inverse x whole square, then show that x square plus 1 whole square y2, that means d square y by dx square plus 2x into x square plus 1 dy by dx is equals to 2. Okay, so as usual, first we'll go for the derivative with respect to x on both the sides. So we'll get it as dy by dx is equals to, so you have tan inverse x whole square, this is theta square. Theta square derivative is 2 theta into derivative of theta. So 2 into tan inverse x, 2 tan inverse x into derivative of theta, that is d by dx of tan inverse x, dy dx of theta. Theta here we are taking as tan inverse x. So derivative of tan inverse x will come. Okay. Theta square, theta value I taken as tan inverse. Theta square is 2 theta into derivative of theta, that is derivative of tan inverse x. So next step, what you get, dy by dx equals to 2 into what you have, tan inverse x. This tan inverse x will remain as this, 2 tan inverse x into, now derivative of tan inverse x, if anyone remember the formula, it is 1 upon 1 plus x square. Okay, this is the derivative of tan inverse x. So the same thing you can rewrite it as 2 tan inverse x upon 1 plus x square. Here you will get, just rewriting the terms in a different way. So this is dy by dx formula. Alright. Now what do you want? You want d square or second order derivative also you require. So if you want the second order derivative, should I write this way? Or in place of this tan inverse x, see here you have y equals to tan inverse x whole square. If I want only tan inverse x, so do the square root on both the sides. So you will get it as a root y. Okay. So you have dy by dx is equals to, if you want, let's write this step, dy by dx is equals to 2 root y upon 1 plus x square. If I do cross product on both the sides, so what do you get? And before this, one more term will come. This will come as 1 plus x square will be here. Just I am sending this term this time. 1 plus x square into dy by dx is equals to 2 root y. Okay, just I am sending the denominator to the LHS. Now if I want to remove the root on both the sides, can I do the square on both sides? Square on both sides. So if I do square on both sides, let's see what you will get. Okay, if I do square on both sides, what we get is exponent will come here and bracket will be there. This is 1 plus x square whole square, 1 plus x square whole square into dy by dx whole square. So here you will get dy upon dx whole square is equals to 4y, because 2 square is 4 and root y whole square is a y. Okay, if I do this way, or yeah. So now what will come? Now again I have to do differentiation on both sides with respect to x. So to do the differentiation on both the sides with respect to x, I'll take this term as u, 1 plus x square whole square, and dy by dx whole square as v. So I have to apply uv formula. So according to the uv formula, first you will get u into derivative of v, derivative of this one. This is theta square. Theta square is 2 theta dy by dx into derivative of theta, derivative of dy by dx. So first order, if I do again derivative, so I'll get it as d square y by dx square. So here you will get d square y upon dx square. I hope this step is clear for you. Okay. Here I am taking as theta as dy by dx. So theta square derivative is 2 theta into derivative of theta. Derivative of theta means derivative of dy by dx. So first order, if I derivative, then I'll get the second order. So u derivative of v plus, here you will get v into, v into derivative of u. Derivative of u means derivative of theta square. Here I take theta as 1 plus x square. So derivative of theta square is 2 into theta, that is 1 plus x square, into derivative of theta. Derivative of theta means derivative of 1 plus x square, which is 2x, is equals to 4. Derivative of y is dy upon dx. Now you see here each and every term. This is my first term, which has dy by dx in it. This is second term, which has dy by dx in it. And this is third term after equal to, which has dy. Even 2 is also there in the first term, 2 is there in the second term. So what I do is I'll take the common few things from both the equations. Let's see what other things will get common. I'll take 2 dy upon dx common for both the terms. Then what are the things left out? Let's see. You left out with 1 plus x square whole square from here into d square y by dx square, because 2 dy by dx is taken common. Okay, plus, then here see 2 into 1 2 is taken common, then you have 2x into 1 plus x square, 2x into 1 plus x square, and 1 dy by dx is also taken common, so another dy by dx will be left out. Okay, this entire thing, I think it has to be in the bracket. Yeah, is equals to 4 dy upon dx. Now what you can say, both the sides, this dy by dx, here also dy by dx will get cancelled, and 2 will get cancelled here twice. Now what you left out here is finally this is equals to 2, because for dy by dx will get cancelled and the RHS 1, 2 will get cancelled. I think this is what you have to do, right? 1 plus x square whole square d square y by dx square plus 2x into 1 plus x square dy by dx is equals to 2. The same thing you have to hold. Okay. So in this example, what you have done is, generally in the previous class we discussed, first you will find d square y by dx square, then you find dy by dx and substitute here, your answer has to come as 2. But in this example, I tried to prove the relation without substituting directly. See, we got the answer directly. We have not done any substitution, d square y by dx square or dy by dx value. Okay, so this is also you can solve, or what you can do is, here you got dy by dx value as 2 root y upon 1 plus x square. Then you find the second derivative, d square y by dx square, by applying uv formula here. Okay. Then all the values you substitute here, then you get the answer as 2. That way also fine. You can use whichever the method is comfortable to use. Okay. Then we'll move to the next example. Here you have differentiate the following functions with respect to x. In the first question, what you do is, just I'll give the hints to you. So it's write out. Keep this cos inverse x as it is. Cos inverse of, put the bracket here, and this is sine. Sorry, not sine, this should be cos, because sine theta you can write as cos 90 minus theta. Sorry, 90 minus x. Can we write? So you have cos inverse of cos theta, which is going to be just theta, that is 90 minus x. Now if I differentiate this one, I'll get 90, derivative of 90 is 0, and derivative of minus x is minus 1. So final answer of derivative will be minus 1. Okay. So in this question, you write sin x by 1 plus x can be written as tan pi by 4 plus x. That we have solved in class 11th also many times. Like you write sin 2x as sin x as 2 sin x by 2 cos x by 2, and 1 you can write as sin square x by 2 plus cos square x by 2, or maybe instead of 1, keep 1 as it is and write in place of cos x, you can write 2 cos square x by 2 minus 1. Achha, let me show you one step so that you will get it. Tan inverse will come here, then you'll get the bracket, then you have fraction. So here you can write it as 2 sin x by 2, 2 sin x by 2 cos x by 2, that I will write. And here what you can write is, in place of cos 2x formula, 2 cos square x minus 1. So here you can write 1, plus, I put minus outside, 1 plus 2 cos square x by 2 cos square x by 2 minus 1. So here what happens is 1 and minus 1 will get cancelled, then 2 will get cancelled, 1 cos x by 2 will get cancelled, so we left out with sin x by 2 upon cos x by 2, which is tan x by 2. So tan inverse of tan x by 2 is nothing but it is x by 2. So derivative of x by 2 is 1 by 2. Okay, so that's how you solve the second question. Now if I come to the third one, let me solve the third question here. Answer the equation what you have, sin inverse. Here it is. Sine inverse. This fraction I'll rewrite the terms in the different way. So 2 power x plus 1, you can write that as 2 power x into 2 power 1. A power x m plus n equals to a power m into a power n. Okay, that you can write. And here 1 plus 2 power x whole square will come, right? This I can write it as, let me put it again here. This you will get 2 power x whole square. Okay, that is a power m whole power n. Generally I do write as 2 power 2 whole power x, because 4 you can write as 2 square. So 2 power 2 whole power x, which is same as 2 power x whole square. Both will remain same. Now after rewriting this, then what I do is I'll replace let 2 power x whole v is equals to some tan, maybe I'll put this as theta, that 2 power x equals to tan theta. So if I replace 2 power x equals to tan theta, let's see what your equation is going to change, how it is going to change. So you will get sine inverse in the bracket, yeah. So if I replace 2 power x as tan theta, so numerator is going to be 2 tan theta upon 1 plus tan theta whole square, that is tan square theta. So let me put this as tan square theta, tan square theta. 2 tan theta upon tan square theta, which is nothing but, do you remember this is the formula of anything, is equals to, this will come sine inverse, maybe if you want to put the bracket, sine inverse of sine 2 theta. 2 tan theta upon 1 plus tan square theta is the formula of sine 2 theta. So sine inverse of sine 2 theta is just 2 theta, which is equals to what you have taken, 2 power x as tan theta. If I want theta value, theta will become tan inverse of 2x. So 2 into tan inverse of 2 power x. Okay, so my function is changed to, the given question is changed to 2 tan inverse 2 power x. So what you can do here is, you can insert whatever the given thing, you can take it as y equals to 2 tan inverse of 2 power x. Okay, now when I differentiate with respect to x on both the sides, then you will get it as dy upon dx is equals to 2 into, so what do you think, derivative of tan inverse theta? Derivative of tan inverse theta is 1 upon 1 plus x square, 1 upon 1 plus x square. Here x is 2 power x, 2 power x whole square is 4 power x. Just now we have done that one. 4 power x into derivative of theta, derivative of 2 power x I have to do. Derivative of a power x is a power x log a. Okay, so derivative of 2 power x is 2 power x into log a, that is log 2. Okay, so final answer is 2 into 2 power x. 2 into 2 power x upon 1 plus 4x into log 2. That is the answer. Okay. Hope you understand this one. So next question is logarithmic question you have to do. Okay. Whatever the question is given, take that as y. I think this method you remember how we solve this thing. I'll take the given question as y equals to here you have bracket, you have sine x minus cos x whole to the power of same, sine x minus cos x. When I apply log on both the sides, so what do you get if I apply log on both the sides? You will get log y is equals to, you will get this sin x minus cos x, okay, sin x minus cos x into log sin x minus cos x. Okay. So when I differentiate with respect to x on both the sides, so you have to apply UV formula. That we are mastering UV formula. Log y derivative is 1 upon y into dy upon dx is equals to, now here I have to apply UV formula, u into v. So what you get UV formula, let me write u into derivative of v. Derivative of v means derivative of this one. So derivative of theta is 1 by theta. Sorry, derivative of log theta is 1 by theta into derivative of theta into derivative of theta is derivative of sin x is cos x. Okay, and the derivative of cos x is minus sin x. Already have minus sign, it will be plus sin x. So u derivative of v plus v derivative of u. So if you want, let me decrease the font size a little bit. Yeah, you got, this is u, so I kept u as it is, and this entire thing is derivative of v, that is derivative of log term. Log theta is 1 by theta into derivative of theta. So u derivative of v now plus v into derivative of u. Derivative of u means derivative of sin x minus cos x. So derivative of sin x minus cos x means derivative of sin x is cos x, and derivative of cos x is minus sin x. Already have 1 minus, so it is going to be plus sin x. Now any cancellations are there, just check it out. This sin x minus cos x and this sin x minus cos x both will get cancelled. So here you left out with sin x plus cos x plus sin x. So now maybe you can increase the font size. So you'll get equation. You have 1 upon y just a minute. 1 upon, font size is not increased. Yeah, 1 upon y into dy upon dx is equals to, so these two terms are getting cancelled, so I have here 1 plus cos x, cos x plus sin x plus this entire term will remain as is. Okay, so what you can do here is you can replace some terms if you want. So replace in the sense, I think you can take cos x plus sin x common from both of them. this 1 upon dy by dx, these terms will remain as is. Okay, these terms will remain as is. I have taken this term common, so then what will left out? Just let me see here. 1 will be left out, plus, and here log. Did they ask you to prove anything? Just find the differentiation. Okay. If you want, you can send y this side. So you'll get dy by dx equals to y into cos x plus sin x into 1 plus log sin x minus cos x. So this is how you'll get the thing done. Okay. Now next example you can take. So this is the question. X under root 1 plus x square, so 1 plus y equals to y under root 1 plus x. So to do the differentiation of this example, sorry, I think font is increased too big. Okay. Now what you have to do is, let me take the given question first of all. Let me write it. What you can write here is, sorry, not this one. You have x. I think is the font size. Yeah, x under root 1 plus y under root 1 plus y. What I do is, I'll take the next term to the right hand side, minus y under root 1 plus x under root 1 plus x. So what I have done here is, just brought the term to the right hand side, whatever the given term is there. So I brought this to the right hand side. So there is a reason why we brought it to the right hand side. So in the answer we don't have any root terms, right? I have minus 1 upon 1 plus x whole square. So before I go for any derivative of the given function, I want to do square on both the sides. If I do square on both the sides, what you'll get? X square into 1 plus y, am I right, is equals to, you will get y square, is y square into 1 plus x, am I right? Now what you can do is, if you want, you can apply UV formula, or let's see if we can do anything simplification further. Just open up the bracket and see if anything much easier you can do. If I open up the bracket, then you'll get x square plus x square into y is equals to, then y square into 1 will be y square plus I'll get y square into x. Okay, so I open up the bracket. So next step what you do is, bring x square, keep x square the same sign, and bring y square to the right hand side, is equals to y square x minus x square y. So what you have done is, I brought this y square term to the right hand side, so it will become minus y square, and this x square y term I brought it to the right hand side. Sorry, this y square to the left and x square y to the right. Just I interchange the terms. So next step what you can do here is, a square minus b square. What is the formula of a square minus b square? A plus b into a minus b equals to, from the right hand side term you can take xy common. If I take xy common, what you left out? Y minus x. Okay, if I take xy common, we left out with y minus x. So next step, let's see what you can do. There are terms which you can get cancelled, but only thing here is I have x minus y and this is y minus x. If I take minus from the common from here, so then you can cancel x plus y is equals to minus x y. This is what you will be left out. Because if I take minus common from this term, you will get x minus y and this x minus y will get cancelled. So minus sign will be there. Now you do the differentiation with respect to x on both the sides. Derivative of x is 1 plus derivative of y is dy by dx is equals to minus, now derivative of xy. I think derivative of xy, I have to apply uv formula. What you get uv formula? U into derivative of v plus v into derivative of u. You get u into derivative of v, that is dy by dx. U derivative of v plus v into derivative of u, that is derivative of x is 1. Next further step, what you can do is open up the bracket and bring all the dy by dx terms one side. So I'll keep this term here as it is. Now if I open the bracket, you will get minus x dy by dx, okay, then minus y. So what you do is if I bring y this side, we make some correction here. Instead of this step, let me remove this step. We are making a mistake here because I want y terms to be one side. So what I do here is, let me insert the equation. I'll keep x here. X is equals to, you may put x equals to minus xy minus y. I'm bringing this plus y to the right hand side, it will become minus y. So in the next step, what you can do is x is equals to, you can take a minus y common. If I take minus y common, I think I'll get x plus 1. Okay. If I take a minus y common, that's what I'm going to get it. So next step, what we can do is, let me insert the equation. You can write this as y is equals to minus x upon x plus 1. Let me put the denominator only, minus x upon x plus 1. So this is what I do so that I can get my answer exactly. Now do the differentiation on both the sides without. So you'll get dy by dx is equals to, now you have minus u by v formula is there. So if I apply u by v formula, so what do you get? First, u by v means v derivative of u. So v means you have x plus 1 v derivative of u minus u derivative of v. Derivative of x plus 1 is 1 only upon v square. V square means you get x plus 1, I forgot the bracket, x plus 1 whole square. Now see if any cancellation, numerator x and x will get cancelled, x and minus x will get cancelled, we left with 1. So I think we got the answer. Okay, so you have dy by dx is equals to minus, numerator only 1 will be left out and the denominator you left out with x plus 1 whole square. Okay. Okay, so that's what the question is asked to prove. So here what we have done in the previous cases, we are differentiated with respect to x, but I'm getting the answer in terms of y. So that's why I changed the question. So I brought all the y terms one side, then take y common. So I got y equals to in terms of x, so that my answer is only in terms of x. Okay. So next question. Now this is interesting one. A little bit lengthy also. Let's see how we'll go about this one. This is the given question. X minus a whole square plus y minus b whole square equals to c square. First sum c is greater than 0. Prove that this value is a constant independent of a and b. Let's see how do I differentiate this one. Okay. So first thing what you do you want me to write the given question? Already you have here x minus a whole square plus y minus b whole square. If I differentiate this one, so I'll get 2 into x minus a into derivative of x minus a will come, which the derivative of x minus a is 1 only, because derivative of x is 1, derivative of a is 0, so it won't affect anything, plus 2 into why I'm putting 2, this is theta square, that is 2 into theta, derivative of theta will come, right? 2 into y minus b, and the derivative of y minus b, derivative of y is dy by dx. Achha. Here dy by dx, and the derivative of b is 0, which is equals to derivative of c square is 0 only, because c is a constant. So first derivative I got it, dy by dx. Now what you want, maybe if you want further one more step simplification you can do here. What simplification you can do here is, you can take 2 common and send that side, so it will come 0 upon 2 is 0. Then you can keep the other terms as it is. If you want, is equals to minus of x minus a. So I send this x minus a term to the right hand side, it will become minus of x minus a. Okay. Or one more step you can write, dy by dx. Let me write that also, because we want all the things. So finally, if you want dy by dx is equals to, you will get a fraction here. This will be x minus a, and here you will get y minus b, and of course there is a minus sign before all. This is dy by dx. When I solve for d square y by dx square, that is second order derivative, let's see what we get. So what you get, d square y by dx square, let me insert quickly. Here you have d square y by dx square. This is my second order derivative. So here I have to apply uv formula, right? So for that I think, wait, this minus then I'll keep as it is and take the bracket. So what you get, u upon v formula. Should I do u by v here, or so instead of applying dy by dx formula here, what I do here is, because unnecessarily I'll get y square d square terms. So to avoid those things, should I? Okay, let it be u by v formula, no problem. So what is the u by v formula say? V, that is y minus b, into derivative of u. Derivative of u is 1 minus u that is x minus a into derivative of v. Derivative of v means here I'll get dy upon dx upon v square. On v square means here I'll get your v is y minus b whole square. If you want to do any further simplifications, you can do. Otherwise, what further simplification? I think this minus sign I can send inside. So what happens is then my terms are going to be d square y by dx square is equals to the same fractions will remain. Okay, just signs will change. This minus sign will become plus sign. So here also it will come control V minus, you will get y minus b here, y minus c upon denominator will remain as it is, y minus b whole square. Okay, so I got dy by dx value, I got d square y by dx square value. Now I have to substitute this equation. This is looking a little crazy. Let's see what I can do here. Oh, sorry. I think I have to type this one. Fraction. Let me insert the equation. Let me font size increases. Then you have fraction. In the fraction, what you have? Is this? No, control Z. First it has to be exponential fraction. Then in the fraction, what you have? 1 plus dy by dx whole square. So 1 plus, and here dy by dx whole square. You have dy by dx whole square, and here you have whole to the power of 3 by 2. So a lot of mathematical steps. 3 by 2 upon d square y by dx square. I think I am right. Yeah. So after getting this step, now I have to substitute what are the values we get it, which is equals to, so first thing you require a fraction, then exponent, then bracket. So here you have 1 plus, what you have, dy by dx. Dy by dx I have is minus x minus a upon y minus b, but here it is, square is there, so minus square will become plus. So what you get here is, so let me put the bracket. So this is x minus, instead of bracket, first I need exponential, then bracket, then fraction. So here you will get x minus a upon y minus b whole square, and here you will go upon 3 upon 2, and the denominator is d square y by dx square. So d square y by dx square means this entire thing will come. Okay. Now what I have to do for this entire thing? So next step I'll put here. Let me see what we can do easiest way. This one. So your denominator I'll keep as it is, no changes. In the numerator, for these terms you can take what you call common. This is x minus a whole square upon y minus b whole square. So before that also I need a bracket here, not bracket, oh, bracket here. So here if I take the LCM, so I need a fraction. So your LCM is going to be y minus b. This is my LCM, y minus b whole square. So numerator you are going to get y minus b whole square plus, here you will get x minus a, not y minus b, x minus a whole square, and here you have still 3 by 2. Okay, so which is equals to, now let me simplify here, first fraction, and the denominator is going to be as it is, no change in the denominator. Okay, so numerator, let me see what are the things can be changed. Bracket, here also the, now here also y minus b whole square will remain same, no change in the y minus b whole square. Now look here, y minus b whole square plus x minus a whole square is nothing but c square. That's what the given question is given. Okay, y minus b whole square plus x minus a whole square is equals to c square. So in place here, I'll put the value as c square. How I am putting? By given equation, whole square. Okay. So next step, what I do here is, you can put the font together. Okay, which is equals to, let me insert the equation and see what will come. Fraction, and still the denominator I'll keep as is, no change in the denominator. What is the simplification I am doing? I am doing in the numerator only. Now see here, you can write this as c upon y minus b whole square, because c square upon y minus b whole square, you can write as c upon y minus b whole square whole to the power of 3 by 2. So 2 will get cancelled. So then finally you left with c cube upon y minus b whole cube. Okay, so you have c cube. So sorry, this is just I am applying the c minus b whole cube. Sorry, c cube. What you left out here is here 1 instead of 2 you will have cube. Now after writing the step, now is there any cancellation? Yes. What are the cancellations you have here is y minus b whole square in the denominator, and this is y minus b whole cube. So that means you can cancel this b square. So you left with numerator, you left with c cube. This you have is c cube, and here y minus b whole square, this is y minus b whole cube. So if square will get cancelled, one y minus b will be left out. Y minus b is left out into this term will be left out. Okay, this is also in the denominator only, so this still remain in the denominator. Now what you can replace in place of this one? What you got, dy by dx value is x minus a. Okay, so till this step we have done it correct. Next what I do here is which is equals to, let me insert the equation. Your numerator c cube will remain as it is, control V, and this terms also will remain as it is. Just a minute. In place of dy by dx, what you got dy by dx value? Dy by dx value I got it is minus, so this minus also I have to copy, minus x minus a into y minus b. So in place of this one, I'm going to replace this with, okay. So here let me put the multiplication symbol so that you won't get confused. Now further simplification when I do here, let me insert the equation. This numerator c cube will remain as it is. Okay. Now look at the denominator. Now I will open up the bracket. This y minus b term will multiply with this term. So here numerator y minus b, denominator y minus b will get cancelled. So you have minus, let me put minus, what you get here, x plus a whole square, sorry, x minus a whole square, x minus a whole square minus, again y minus b will multiply with this y minus b, it is going to be y minus b whole square. Agree? Sorry, here it will come y minus b whole square. Let me put the bracket, y minus b whole square. Okay. If I take y minus b whole square, minus common from both the terms in the denominator, what will you have? So you will have is equals to, last step we are doing, we'll finish it off early. So you have here c cube in the numerator, c cube in the numerator, denominator is minus, if I take minus common, here x minus a whole square plus y minus b whole square, which is nothing but c square. That is the given question, okay. So finally my answer is going to be c cube upon c square is equals to minus c. So I got the final answer is minus c. So what is the question is asked? Prove that is a constant independent of a and b. Yes, I got the answer as c, which is independent of a and b value, where c is a constant. I have one more question, just you can try think e power theta, derivative of e power theta is e power theta into derivative of theta. Derivative of theta means derivative of a into cos inverse x. Derivative of a into cos inverse x is, I'll show you, I think this is question number 23, right? Here. So here e power theta into derivative of cos inverse x. Derivative of cos inverse x is minus 1 upon under root 1 plus x square. So if I replace this e power a cos inverse x as y, because that is what they are given y value. So finally I left with minus ay upon under root 1 minus x square. So if I do square on both the sides, dy by dx whole square equals to a square y square upon 1 minus x square. Send this 1 minus x square this time. So you'll get 1 minus x square into dy by dx whole square equals to a square into y square. Now you apply uv formula on both the sides, u derivative of v plus v derivative of u. That's what they have done. U derivative of this one, dy by dx whole square. So 2 dy by dx into derivative will be d square by dx square. So after simplifying, you will get the final answer. Okay. So we completed our chapter successfully. If any doubt, let me know. Thank you. Have a nice day. Bye bye.